All right, so today we're starting off Unit 3 talking about average rate of change. So we're going to talk about what is it, we're going to calculate it, and then we're going to do some more calculations with it, and we're going to do some talking about what it is. So average rate of change is how a graph or function moves or changes throughout the graph. So how a graph or function changes or moves through the graph. So back in Algebra 1, you did talk about this a little bit. And you were probably told that it's like slope, which really it is. Average rate of change is like your slope. You're trying to find the slope of any given function, but we don't call it slope because the only function that has a slope is your linears, your mx plus b, m being your slope. So with the average rate of change, what we're essentially doing is on any function, we're using 2 points on that function to find how is that graph changing between those 2 points. So let's draw a little picture here. Let's say we had a quadratic function. And I wanted to know what is the average rate of change from this part of my quadratic to that part. So what we do is we use those 2 points between the 2 parts we're looking at. And essentially we're trying to find the slope of that line if we were to connect them. That is our average. So it's taking the average of all of the different rates of change from here to here. We're using the average by kind of making a line and finding the slope of that line. So that's why people say it's like slope. So you're just trying to find that change between those 2 points. The way we do it is we use that slope formula. So our formula here, our notation for it, there's a lot of different ways that they write it. So our notation for our average rate of change can be just like your slope formula, y2 minus y1 over x2 minus x1, or they could use some function notation in there, which again, this is the same thing, because if you remember, f of x and y are interchangeable. Y is f of x. And that can go reversibly. F of x is your y. So those 2 things are interchangeable. So whether we actually say y2 minus y1 or f of x2 minus f of x1, we're saying the same thing. So your average rate of change looks a lot like your slope formula. It's very similar to it. So what you have to keep in mind also is x1 and y1 equals your first point. x2, y2 equals your second point. Or if it says x1, f of x1, first point, x2, f of x2, second point. So as we can see here, the top and bottom values, those are from the same point, and these ones are from the same point. That's the way it always goes with our slope formula. That's the way it's always going to go with our average rate of change formula. So then the other thing to keep in mind is when they're asking you to find the average rate of change, they're always going to give you the domain values. Okay? Always gives you those domain values. So what you need to do is you need to find the range values that go with it. Find range to go with them. Because you need to have points. So you're given the domains, you got to find the ranges that go with them so that you can actually calculate your average rate of change. You need 2 full points in order to find that average rate of change. So then something else to consider with our average rate of change, which I do tend to shorthand to AROC, average rate of change. Average rate of change can be so many different styles. So it can be constant. So if you have a constant average rate of change, that means it's always the same. Your graph is always increasing the same, or it's always decreasing by the same. So an average rate of change that's constant is what we see in our linear functions. Your lines are straight lines. It's always increasing or decreasing by the same amount with that slope, which is a constant value. Then they can also be increasing or decreasing. So what that means is from one point to another, it could increase by 1, but then the next points could increase by 2, and then the points after that are increasing by 3. So your average rate of change is also increasing because it was going up by 1, and then it's going up by 2, and then it's going up by 3. So the amount it goes up by also is increasing. And it can go the other way too for decreasing. So it could be going down by 4, and then down by 2, and then down by a half. So that would be a decreasing average rate of change. So you can have increasing, decreasing, or constant for your average rate of change. Or there'd be no pattern at all. That's also a possibility. So let's take a look at our first example. Let's practice this a little bit. So find the average rate of change given this function here. So I have f of x equals 3x minus 6. So again, these are our intervals. These are our domain intervals. As I said, your domain intervals are, they're just your x's. So here we have -3, 5. So what I need to do is I need to find those range values that go with it. So if I take -3, plug it into my x up here, I get -9 minus 6. That's going to give me a -15. So I have the point -3, -15. And then if I take my 5 and I plug it in, I have 15 minus 6. So that's going to give me a 9. So now I have my 2 full points, whereas I just had my x's before. I now have my full points. So now I can actually calculate my average rate of change. Y minus y over x minus x. It does not matter which point you put first as long as these two values here are from the same point. So this ends up giving me 24 over 8. So I have an average rate of change of 3. So from where x is a -5 to, where x is a -3 to where x is a -5, my average rate of change is a 3. All right, let's try it for the next set. So we're going from 0 to 4. So again, 0 and 4, those are our x's. I need to find the y's that go with it. So if I plug 0 in here, I get a -6. If I plug 4, I get 12 minus 6 gives me a +6. And so now we do our slope formula. Y minus y over x minus x. So that gives me 12 over 4. So I get 3. So from 0 to 4, my average rate of change is 3. So then last set of, in the last interval value that they, or range that they want us to look through, -1 gives me a -9, because that'd be -3 minus 6. +1 gives me a -3. So there's my 2 points. So -9 minus -3 over 1 minus -1. I did that backwards. -9 minus -3, which would be -1 minus 1. There we go. I flipped them. So that gives me -6 over -2, which gives me 3. So again, my average rate of change is 3. So what this is saying is no matter what interval range I looked at, -3 to 5, 0 to 4, or -1 to 1, my average rate of change is a 3. It is always a 3. So what that's saying is our linear functions the average rate of change is always constant. And that's what we had here. 3x minus 6, that is a linear function. So our average rate of change was constant. No matter which interval range we looked at, it was always a 3 because your linear functions are always constant. All right. So let's take a look at a different function. So this time we're going to be looking at our quadratic function. We have 2x squared minus x here. Same interval ranges, -3 to 5, 0 to 4, -1 to 1. So we're going to see what happens as we play around with the range that we're looking at. So 2x squared minus 2. So I'm going to start with -3 and 5. So if I plug in -3, that gives me 9, 18, plus 3, that's going to give me a 21. Plug in a 5, I get 25 times 2 is 50, minus 5 gives me a 45. So now I'll do my average rate of change for this. So 45 minus 21 over 5 minus -3. So that gives me a 24 over 8. So an average rate of change of 3. So from -3 to 5, my average rate of change is 3. So let's try our next interval, 0 to 4. So if I plug in a 0, I get 0. If I plug in a 4, I get 1632 minus 4 gives me a 28. Okay, so 28 minus 0 over 4 minus 0 gives me 28 over 4, which is 7. Our average rate of change changed. It was a 3 from -3 to 5, but now from 0 to 4, it's a 7. So not constant with our quadratic here. Linears always. So our last range, if I plug in a -1, I get 2 plus 1, so that gives me 3. If I plug in a +1, I get 2 minus 1 gives me a 1. So 3 minus 1, -1 minus 1 gives me 2 over -2, so I get -1. Which does actually make sense for our quadratic function. If I draw a quick little sketch of it. That's going to be going up. This side of it is decreasing. So yes, I should have a negative at some point because part of my quadratic is decreasing. So it does make sense that that's there. That is perfectly fine for that to be there. And then we have part of it's increasing. So for our quadratics, so quads, the average rate of change can be increasing or decreasing, depending on the part of the graph, depending on what part you're looking at. So depending on what part of the graph you're looking at, they can be increasing or they can be decreasing, as we have seen right here. There is no real consistent pattern with that like we had with our linears or like we do have with our exponentials, and we'll talk about that a little bit more. So the other thing we're going to take a look at, so go on to the next page in your notebook. We're going to actually write some notes down in there, and we're going to talk about comparing the average rate of change, okay? So just go to a blank sheet. When comparing average rates of change, comma. Always use the absolute value of the rate of change. Okay, when comparing the rates of change, always use the absolute value of the rate of change, because positive and negative, all that does, or negative, shows what direction it's going in. So that just shows the direction that you are going in. So if you have a positive rate of change, that just shows us that the graph is going up from the left to the right. If you have a negative rate of change, all that is showing us is that the graph is going down from the left to the right. So negative just simply shows us direction. Okay, so a couple of problems that I have here for us to look at. We're going to compare which function has the greater rate of change, which is kind of the whole reason we look at rates of change, is so that we can then compare the functions together. So let's say I have the function f of x equals 5 to the negative x. And then we'll say the other one is a table for g of x, negative 1, negative 2, negative 3, negative 4, 4, 16, 64, 256. And we'll look at the interval of negative 4 to negative 1. They always give you what interval to look at, so don't ever worry about trying to have to pick it. It's always given to you whenever you're given a problem. So what I need to do is, using my calculator, I'm going to find the y values that go with negative 4 and negative 1. Again, that's the interval they told us to use. So I'm going to plug negative 4 in for x, and that's going to give me a 625. Plug in a negative 1. That's going to give me a 5. So I'm going to do my average rate of change. So I'm going to get negative 620 over 3, which is a negative 210. So my average rate of change from negative 4 to negative 1 on this function, my f of x, is negative 210. All right, the other one, because it's a table, they already gave me my points. We don't really have much work to do other than finding them off of the table. So 256 minus 4 over negative 4 minus negative 1 is going to give me a 252 over negative 3, which gives me negative 84. All right, so now I have my average rates of change. Sorry, my 84 is kind of a messy there. That's a negative 84. So again, negative doesn't matter. So I just almost pretend like it's not there, because negative is just telling us a direction for the rate of change. These would all be decreasing graphs. So average rate of change, the one that has the greatest average rate of change, is going to be our f of x. Because 210 is larger than negative 84. All right, let's try another 2 more. Same directions. Which one has the greater rate of change? Only this time we will be using f of x is a negative 3x plus 5. G of x is 1/2 x squared. We will be using the interval of 0 to 4. So again, 0 and 4, those are our x's. So I have to plug in my numbers to get my y. So if I plug in a 0 here to f of x, I get 5. Plug in a 4, I get negative 7. So let's see here, that's negative 7 minus 5 over 4 minus 0. Negative 12 over 4 equals negative 3, which I didn't even really have to do because it was right there in your function. So if you can recognize that, by all means, go for it. So g of x, if I plug in a 0, I get 0. If I plug in a 4, I get an 8. So I get 8 over 4, which is a 2. So again, comparing which one has the greater average rate of change. I don't care that this is a -3. I'm just looking at the rate of change is a 3, the rate of change is a 2. F of x, yet again, is greater. So when you're comparing, negative doesn't matter. You're just looking at what the rates of change are. This is a change of 3, that's a change of 2. Whereas up here, that was a change of 210, that's a change of -85.